Okay, so we're continuing on Big Java Early Objects 7.2, and we are talking about the common array algorithm. So we have multiple things that we can do, the algorithm for the arrays, and some of them you should be familiar with it, coming in with some background in programming. Some of them might be new to you. So we are filling up my array with some sequence. So how do we come up with this sequence? First, we have to pay attention to see how do they work. So this is the first one is 0, second one is 1, third one is 4, 9, 16, and so on. So this is basically doing the square on my index. So I'm going to have a loop to start with 0, and then of course I'm going to go to the lengths, and then I'm going to say I'm going to multiply my index, whatever I have, by itself. That's going to make it a score for me, and then I put it back here. So that's one thing that we can do. Next one is for the sum and average. I'm not going to go through details of these things. You just go through it and you just add it to your total, or we are going to calculate the average. And you can see that we are checking something. Again, the checking is important. So in this case, I am going to be checking the lengths of it. Why? Because if the length of my array is 0, meaning it's empty, doesn't have anything in it, or it's not pointing to something correctly, then it goes here and nothing coming out of it. And then when I divide it by the lengths, then I'm going to have a problem because it's a division by 0. Exception is going to be true, a division by 0. So I'm checking to be sure the length is more than 0 before I calculate my average. If it's 0, then I'm not going to do anything. If it's less than 0, I'm not going to do anything. Of course, you cannot have the length of your array to be a negative number, but the point here is we are not going to do anything about it. We are not printing anything. We are just not doing anything about it. And finding minimum maximum. So what we're going to do is we're going to set the first one to whatever we want, largest or the smallest. And then we're going to go through the array. As soon as we find something, we're talking about the maximum over here. As soon as we find the element that's larger than my maximum or the other way, and then we're going to set it to that one. So I'm going to be looking through the whole array. Remember, I'm going through the whole length. And if it was partially filled array, then I wouldn't go to the lengths. I would just go to the number of elements that I have, which we call it current size. So we could go to current size if it's partially filled, or we can go to the lengths if it's fully filled. And then we are going to be starting with 1. Why do we start with 1? Because we already used 0 over here. So we're going to put the first element in our maximum or minimum. Then we're going to go start from 1 to the lengths. And then we're going to go look through it. And as soon as we find something, in this case for the maximum, if my value is greater than maximum, then I'm going to set my maximum to that value. And if we're doing the minimum, it would be the other way around. We can put some separators with those things. So if I want to print my array with some separators, we can think about it that we are printing these things after our element, or we can think about it before it. Either way, we got to catch one extra. So if I'm thinking it's going to come after my element, I've got to be sure I don't put anything here. If I'm thinking that's coming before my element, I want to be sure that's not going to happen over here. So either way that you're doing, you got to check for the extra one so we don't put the extra one in there. So in this case, we are checking for the 0, then we're going to print this one. Next one is linear search. Linear search means that we're going to start from the beginning. We're going to go to the end. We're going to be looking for the element that we are looking for. And then as soon as we find out where it is, we're going to return the index. So we are having some kind of a what we are looking for. That's going to be search value. Either we read it from the users coming from somewhere, however it is, we are looking for that one. So we have a position, we're going to start with 0, and we have a Boolean that's going to be set to false. And then we're going to say, as far as this position is less than the length, we don't want to go outside of our array, and it's not found. Okay, so that means what? The false, not false is true. So as soon as we find it, wherever we find it, we're going to change the font to true. So this loop can stop if I get the true, or if my position becomes equal length. So if my position becomes a length, then we're going to say it's not found. Generally, if you put this in a method, you would not write in your method. You're just going to return something. So what do I return to indicate the calling method, or whatever is calling my method, that it doesn't exist? So we do have index from 0 to the length. So if I find it at the beginning, it's going to return 0. If it's going to be in the middle, it's going to return that number. So in a general sense, if I don't find it, I'm going to return -1 because I cannot have a negative index. So the calling, whoever is calling this method, if it sees -1, that means it's not found. And if it sees an index, then it knows it did find it. All right, now, when we are adding or removing to the array, two things can happen. One is my array is sorted, or the order is important. So I have test 1, test 2, test 3, test 4. So it's that order, or I have it as sorted. So the order matters. If the order doesn't matter, what I'm going to do is we're going to take the last element. We're going to take the last element. We're going to put it on top of what we are trying to remove. So we are trying to remove this 34.5, whatever element is. In this case, 0, 1, 2, 3, 4. So we want to delete index 4. So what we're going to do is we're going to say index 4 is equal to the last element that we have, which is the current size -1. And then we're going to update our current size. So even though that 65 stays in the array, our current size is going to be decremented. Remember, when we have the current size, the loop is just going to be looking at the current size. It doesn't look at the whole array. So we don't move it, we just copy it to another location, and then we move the current size. So from this point on, my current size is going to be pointing to this area. So even though it's in the array, I'm not looking at it anymore. So that's the way we're going to remove it if it is not, the order does not matter. Now, what about if the order does matter? That means, so we put the position into values current -1, and then we're going to update the current size minus. Now, if the order does matter, that means I have to move things up. That means I have to, I want to delete this, so I have to bring this one on and put it. So 115 goes on top of 80. Then 44.5 goes to 115. 100 goes to 44.5, 65 goes on 100, and 65 goes on top of 65. We're going to decrease the size, current size. Then we're basically going to be looking at our current array up to this point. So we're going to create a for loop. We're going to start with this index that we're going to have, +1. So, and we're going to be going up to current size. Remember, this array can be much longer than what we're seeing over here. So we go up to current size, and then we're going to say values I minus 1 equal I. Now, remember, we're doing the I. So whenever we're doing a minus, we have to be sure we are not going to fall off on the other side. So how could I fall off on the other side? So if my I was 0, this could give me a negative number. Now let's be sure that I cannot be 0 at all. So in this case, even if the position is 0, my I is going to be position +1. So my I can never ever be 0. But I'm checking to be sure that's not going to be the case. Same thing goes with the insertion. So if the size does not matter, we're going to add it to the end of our list, and then we're going to update our current size. But again, if I'm going up that way, I have to be sure that I have a room to put it in there. So we're going to go, if the current size is less than values.length, we have to check it because we don't want to insert something that's going to go outside of my boundaries. So we're going to say current size plus. We're going to add 1 to it. And then we're going to say value current size -1. We're going to put it in there. So we're going to put it in the last element. We're updating our current size. Now, this is if we don't have something ordered. It's not sorted, or it's not, the order doesn't matter. But if the order does matter, we have to do the same thing. So if the order matters and I want to put something in here, then I have to move everything down. So that's the work that we need, and we're going to appreciate array list on the second part of this chapter. So next one is a swapping. So if I want to swap 2 elements on my array, I have to put one of them in the temp, put the second one in the first one, and the first one into the temp into the second one. So we're going to get the value I into the temp, and then we're going to put the I equal J, and then we're going to put the temp back in the J. That's the swapping an array, and most of you should know that already. Copying an array. So because we have a fixed size of array, there is a possibility that we're going to run out of size. Or remember, because array is an object, if you put one equal the other one, is going to copy the address, not the actual object. So we have a method inside the arrays. So we're going to say arrays.copy of, and then we're going to say the array that we want to copy, and then we're going to put how much do we want to copy. So in this case, we want to copy everything. So we can have everything. We can have, let's say, the first 5 or whatever we want to do. So we're going to copy that many elements of this one into the other one. So basically what's going to happen is we're going to create a new array and we're going to copy it. So we don't have to do it manually. The Java behind the scenes is going to do it for us. So for that, of course, we need the Java util arrays as the import. So remember, if I have something like this is going to be copying just the address. This is not what we want. They're going to be pointing to the same thing. Now, what about if I have an array and then I am running out of space? So in C++, we cannot do anything about it. So I thought that the maximum number of students in my class is going to be 35. I created an array of 35. Now I have 36 students. I cannot do anything about it. But in Java, what we can do is we can create a new array with the new size and copy stuff over. So that's something that we can do here. So we gonna do arrays.copy of. Now we have the array that we want to copy, and that the size is going to be 2 times length. And then, so that's going to be the new values. So now I'm going to have 2 arrays. One was with the first size, let's say was 10. Then we create one with 20, we copy it over. Now we have these 2. But in most of the time, I don't want to have 2. I want to put the second one on top of the first one. So this is the way we're going to put it on the first one. So my new values, I'm going to put it in the values. Now they both are going to be pointing to the same location. Remember, Java has garbage collector, meaning that if your object goes out of scope, you don't need to clean it up. It has something just like Python that goes, it doesn't do it right away, but it goes around, and when it sees that there is nothing pointing to this object, it's going to clean it up. So they have garbage collectors. So if this one new value goes out of a scope, then or any of these things, it's going to clean it up for you. You don't have to worry about it. So another one is to read the input. So we're going to read the input, and now we find out that the current size is going to be, so we are running out of space. So as soon as we're running out of space, what do? We don't say to the user, don't give me any more. We're going to make our size double, and then we're going to copy it over. So that's what we're going to do. And then we're going to start reading again. So the inputs, which is our array, is going to be equal arrays.copy of inputs, 2 times. So we don't create a new array. We just create a new object of array in the memory, and then we're going to put it in the input. So the previous object is going to go out of the scope, and Java is going to clean it up for us. I don't have to worry about it. So I started with some size. I ran out of the size. I need more size. I'm going to double my size. These are what we're doing in this code. And then I'm going to assign it to the same variable. That means my previous object is going to go out of scope, and it's going to be cleaned up later. So that's the one that you have as a sample in your book. And I'm going to stop here and you can do the self-check starting with 7:13.